learners, welcome to SWAYAM Online lecture series on the topic Database Management System. Myself, Mohammadullah Bukhari, working as a professor in the Department of Computer Science at Aligarh Muslim University, Aligarh. I am pleased to have you join me today as we explore the fascinating realm of database and database system. In the next few minutes, we'll discuss about dependencies, preserving, decomposition, and functional dependencies. In the last lecture, I have discussed about the decompositions. So today we'll discuss about the functional dependencies that form a backbone of modern information system. In the previous lecture, we have discussed about the introduction of concurrency control, understanding locking mechanism, transaction isolation level, different types of transaction isolation level we have discussed, two-phase committed protocols, deadlock detection and preventions, optimistic concurrency control, multi-version concurrency control in NoSQL I have discussed in detail, and the last one exploring isolation anomalies in database transactions. And also I have discussed about the impact of concurrency control on database performance. Before going to discuss today's agenda, I would like to answer of the question which I have given in the previous lecture. The first question was, what is the concurrency control in database management system and why it is necessary? Concurrency control in database management system is a set of techniques and mechanisms that ensure the consistency and correctness of database when multiple transactions are executed concurrently. In a multi-user environment, multiple transactions may be tried to access or modify the same data simultaneously. Without proper concurrency control, this can lead to several issues, including data inconsistencies, lost updates, and incorrect queries results. Therefore, concurrency control is necessary to maintain the integrity of data in such situation. Can you explain the concept of deadlock in concurrency control and how it can be prevented or resolved? The answer is, a deadlock in concurrency control occurs when two or more transactions are unable to proceed because each is waiting for the other to release a resource, such as a lock, and as a result, all transactions involved come to a standstill. This situation can lead to a significant disruption in the system operation, hindering overall performance. Deadlocks typically arises when transactions acquire locks on resources in a way that creates a circular wait dependency. The next question was, explain concurrency control in NoSQL database in detail. Concurrency control in NoSQL database involves managing the simultaneous access and modification of data by multiple users or transactions in a distributed and non-relational environment. Unlike traditional relational database, NoSQL databases, which includes various types like document-oriented, key-value store, column family store, and graph database, often prioritize scalability, flexibility, and horizontal partitioning over a strict consistency. The last question, what do you mean by two-phase commit protocol, and explain in details? The answer is, the two-phase commit protocol is a distributed transaction protocol designed to ensure atomicity in distributed environment where a transaction span multiple database or resources. The primary goal of two-phase committed is to coordinate the commit or abort decision of a transaction across all partitioning nodes, ensuring that either all the nodes committed to transactions or none do. The protocol consists of two phases, the prepare phase and commit or abort phase. So the today agenda is we'll discuss about dependency preserving decompositions, functional dependencies. Let's start one by one. Dependency preserving decompositions. It means when you are decompose a relation in normalization, then a relation must be FD preserving. I mean to say that dependency preserving decomposition is a process in database normalization where relation is decomposed into smaller tables while ensuring that the functional dependencies present in the original relation are preserved in the decomposed table. It means all the functional dependencies must be preserved. I mean to say that when you will join the decomposition, then we are able to find all the attributes, all the functional dependencies. This means that any dependency that exists in the original table should still be represented in a smaller table after decomposition. Preserving dependencies ensure that the data integrity and relationship between attributes are maintained, allowing for efficient querying and manipulation of data across the decomposed table. Dependency preserving decomposition ensure that the decomposed table can be joined back together to retrieve the original information without losing any essential relationship or constraint. So here we'll discuss about the steps of dependency preserving decomposition. How you will check? Identify functional dependencies. We start by identifying all the functional dependencies that exist in the original relations. Then analyze dependencies for preserving. What to do? Examine the identified functional dependencies to determine which dependencies need to be preserved in the decomposed relations. Then choose the decomposition strategies. Decide on the strategy of decomposing an original relation in a smaller relations. There are various techniques available such as lossless joint decomposition, dependency preserving decompositions, Bossy-Code normal decompositions, perform decompositions, verified preserving, normalized further if necessary, review and refine. These are the steps you have to follow. Choose a decomposition strategy. So there are various types of lossless decomposition. Decompose a relation in such a way that the original relation to be reconstructed through a join operation without losing any information. It means when you will join, suppose a relation R, you have decomposed into R1 and R2. When you will join R1, join R2, then we are not able to lose any information. Dependency preserving decomposition that ensure the functional dependencies identified in the steps 1 are preserved in the resulting decompositions. It means we are able to, when we are decomposing a relation, that must be none FD preserving. It will must preserve all the FDs. I mean to say we are not able to losing any attributes. Basic code normal form, decomposition, decompose a relation into a smaller relation that are in BCNF, which eliminates all non-trivial functional dependencies. Perform decomposition based on the chosen decomposition strategy. Split the original relation into a smaller relation tables while ensuring that the functional dependencies are preserved. I have already explained. So these are the steps you have to check. These are the steps you have to check. Verify preserving. After decomposing a relation, verify that the functional dependencies identified in step 1 are still present in the decomposed relation. Ensure that the decomposed relation satisfies the requirement of normalization and maintain the integrity. Normalize further if necessary. It means depending on the normalized level desired and the specific requirements of the database schema, further normalize the decomposed relations if necessary. Normalize the relation to higher normalization BCNF 4NF to eliminate the remaining redundancy and anomalies. So how you will go to further decomposition? For that, I have already explained in the previous lecture that you have to check a decomposed relation, all the three anomalies: insertion anomaly, deletion, and updation anomaly. If it will satisfy, then we no need to decompose the relation. Review the decomposed schema to ensure that it meets the design goal, performance requirement, and business constraint of the database system. I'm taking one example. Consider a basic, you can see on the screen, consider a basic example of functional dependencies decomposition using a table called imply project with three attributes. You can see on the screen: imply ID, project ID, and the imply name. Each employee works on a project and we want to decompose a table while preserving functional dependencies. We have to decompose. The functional dependencies is given on the screen. You can say imply ID determines imply name. It means imply name is fully dependent on imply ID, or you can say imply ID determines the project ID and imply name also. The project ID determines imply name also. Now let's decompose this table while preserving these dependencies. The first step is to identify the functional dependencies. We have two functional dependencies. One is imply ID determine imply name, and project ID also determine imply name. Analyze dependencies for preserving. We need to ensure that both these dependencies are preserved in the decomposed relation. Choose decomposition strategies. We will choose the decomposition strategy that allow us to create a smaller relation while preserving the functional dependencies. So perform decomposition. We decompose table into two smaller relations. So one relation, imply details, that attributes contain imply ID and imply name, and reason imply ID determine imply name preserved. So you check, oh, this is good. Then you can see on the screen the table. Imply details contains the imply ID and the imply name. Imply ID 101 John, 102 Mary, 102 David. Same way, the project imply name you have to make one relation. Attributes is project ID and imply ID. Project ID determines the imply name preserved. So here you can see on the screen project ID and project ID. One project ID 201, imply ID 101, 02, 102, 103. So then here you have to verify the preserving. Both the functional dependencies are preserved in the decomposed relation. So we go to normalize further if necessary. The decomposed relation cannot be further normalized if required, and review the decomposed schema to ensure it meets the design goal and requirement. In this way, we can decompose a relation in such a way that we are that decompose is lossless and FD preserving. Then come to the point of what is functional dependencies. Functional dependencies is a cornerstone concept in database management system within the realm of relational database. It defines the relationship between attributes within a table, elucidating how the value of one attribute hinges on the value of another. Suppose imply ID determine name. It means imply name is fully dependent on imply ID. Imply ID determines a imply name. If two attributes exist, functional dependency signifies that knowing the value of one attribute allows us to deduce the value of another. This relationship is pivotal for data integrity and efficiency in database design. For example, you can see on the screen imply ID and imply name and the ID department. The name of the imply name is functionally dependent on the unique identification of imply ID on the primary key. It means every table must have a primary key. The different, and we'll discuss about the types of functional dependency. There are different types of functional dependency: simple functional dependencies, composite functional dependencies, transitive functional dependencies, partial dependencies, multi-value dependencies. So let us start simple functional dependencies. These are basic form of functional dependencies where one attribute uniquely determines another attributes already. For example, in a table imply, each imply has unique ID. Then imply ID determines imply name, represent as simple functional dependencies. The next example, I have taken an example, you can see on the screen, the imply ID and imply name, implied ID. In this table, each imply ID corresponding a unique name. Therefore, we can say that imply name is functionally dependent on imply ID. This dependency is denoted by imply ID determines imply name. So these are example for that. Then the example of composite dependencies. In this type, a combination of attributes determine another attributes. For example, we can say that the combination of here on the screen you can see customer ID and product ID determines the quantity. It represents a composite functional dependencies. Example, you can take an example. Suppose we have a table name order with the three attributes: customer ID, product ID, and the quantity. Each order consists of customer purchasing a quantity of a specific product. In this table, we can say the customer ID and product ID together determines the quantity. If the product purchased, so we have the functional dependency will become customer ID, comma product ID must determine the quantity. It means quantity is fully dependent on the customer ID and the product ID. So the combination of customer ID and the product ID acts are determinant attributes set because both values uniquely determines the quantity order. So the combination of customer ID and the product ID acts the determinant attributes set because knowing both value uniquely determine the quantity orders. So this is called composite functional dependencies. It means the quantity is dependent for both product ID and customer ID here. The next is transitive functional dependencies. Transitive functional dependencies occurs when the value of one attribute determines the value of another attribute indirectly through third attributes. For example, we can say that a relation consists of attributes a student ID, course ID, and the professor ID. If a student ID determines course ID and the course ID determines professor ID, then we can say that a student ID determines professor ID is a transitive functional dependencies. So for that we have taken one example. You can see on the screen a student course with the three attributes: a student ID, a student course ID, and professor ID. Each student is enrolled in a course and each course is taught by a specific professor. In this table, a student ID determines course ID. Each student is enrolled in a specific course and each course ID determines professor ID. It means each course is taught by any professor. So we have the functional dependencies. A student ID determines course ID and the course ID determines professor ID. So now let's consider that transitive functional dependencies. Since a student ID determines course ID and course ID determines professor ID, we can infer that a student ID indirectly determines professor ID through a course ID. Therefore, we have a transitive functional dependencies. It means A determines B or B determines C. I mean to say that we can say that A determines C also. This is called transitive. So here you can on the screen you can see a student ID determines professor ID. Then we can say that the other is partial dependencies. Partial dependencies occurs when attributes is functionally dependent on only a part of a composite determinant. This violates the principle of normalization and can lead to a data redundancy. For example, in a relation A, B, C, their relation contains a relation. For example, if a relation contains three attributes A, B, C, the functional dependencies are given A, B determines C, A determines C, then we can say that B determines C represent a partial dependencies. On the screen you can take one, I have taken one example. Suppose we have a table name imply project with four attributes: imply ID, project ID, imply name, and project name. Each employee works on a project and we want to track both the employee's information and the project information. So in this table, employee ID uniquely determines the employee name and project ID uniquely determines the project name. However, you can say employee name is functionally dependent on the employee ID, which is a part of a candidate key, and the project name is functionally dependent on the project ID, is also a candidate key. So we have the following functional dependencies. Employee ID determines employee name and project ID determines project name. Now let's consider the partial dependencies. If we take the combination of employee ID and project ID as the candidate key, we can see that both the employee name and project name are functionally dependent on this composite key, employee ID and the project ID. Employee name is functionally dependent on the employee ID, and project name is also functionally dependent on the project ID. So come to the next, multi-valued dependency. In multi-valued dependency, one set of attributes uniquely determines another set of attributes, but the dependency does not hold for individual attributes within those sets. Multi-valued dependencies are usually found in a table that are in the basic code normal form. For example, we have a table name imply a skill with three attributes you can see on the screen: employee ID, a skill, and proficiency. Each employee possesses multiple skill, and each skill may have different proficiency skills levels, or you can say, and each skill may have different proficiency levels. So here employee ID is 101, skill is a Python, he is expert, and also one employee ID 101 have a skill is SQL and intermediate. 102 have SQL and proficiency is expert. In this table, we can see that each employee can have multiple skills, and each skill can have multiple proficiency level. The combination of employee ID and a skill determines the proficiency, but proficiency is not functionally dependent on either employee ID or a skill individually. So we have the following multi-value dependencies are: employee ID, comma skill determines proficiency. It means proficiency is fully dependent on the both attributes employee ID and a skill. Hence, the double arrow symbol indicate the multi-value dependency. Now let's assess your knowledge and track your progress with few questions I have given you. Hope you will do as assignment. It will improve your understanding of today's lecture. The first question is: explain transitive functional dependencies. What do you mean by dependencies preserving decomposition, and explain in details. Describe multi-value dependencies. What are the advantages of dependency preserving decompositions? In our exploration, we investigated. In our exploration today, we navigated the intricate world of functional dependencies and the decomposition of functional dependencies. When we decompose relation, that must be lossless and preserving. So that discussion will be very fruitful for designing of database design for modern information system. Thank you for your active participation, and we eagerly anticipate your presence in our upcoming lectures. Wish you a wonderful day ahead.